Good day, students. So we are now again in our practical research 2. So we are now in our uh, ninth module in our second quarter. So this is about analyzing bivariate correlation. So after we made our methodology, we gathered the data. So we are now ready to analyze the data that we collected through our data gathering through surveys. So we have different ways to analyze data as presented in module 7. So we'll begin with the correlation, okay, or the test of relationship between your variables, okay. Okay, so let's have this introduction. So I guess you have always thought about how it's going to be easier to study if your room was colder or more comfortable. So where your thought is the more comfortable your room is, the better your grades will be. So maybe you have always thought that the higher your allowance in school is your motivation. So the better your grades will be. So I think you have always thought that your classmates or friends think the same, while those thought run through your mind. Okay, so what you're actually trying to do at those times when you're thinking about them is testing if there is a relationship between those two variables. So in the situation presented earlier, so we're trying to test if there's a relationship. Example, in your room. So if you have a comfortable room, would it result to higher grades? Okay, so if your room is not well ventilated, so will it result to lower grades? Okay, so those ideas in your mind represents a test of relationship. Okay, so Hahnemann et al. Considers this comparison as a vital part in testing your hypothesis, since comparing groups is actually one application of the idea of statistical association. So this statistical technique can be useful if you want to prove that a statistically significant relationship exists between your chosen variables, but can't answer if your crush has a relationship with your friend. So just concentrate first on your studies. Okay? So let's proceed to our topic. So what is correlational analysis? So the easiest way to define this is the relationship or linkage of two variables. Looking at the variables, if they co-occur, correlate, or go together, so therefore, you will only use statistical techniques pertaining to this. So if you want to find the relationship, magnitude, direction, and significance of two variables. So the correlation R can take a value of -1 to +1. So remember that. So a value of 0 shows that there is no association between the two variables. When there is a positive coefficient or R is greater than 0, this means that as one variable increases, so does the other variable also increase. Okay? Then a value of negative coefficient or R is less than 0 means that if a variable increases, the value of the paired variable decreases. So opposite. So if R is negative. However, correlation does not mean causation. So it is by Sowell and 1 and Tabasnik and Fidel 2003. So the only way to establish causation is through experiment and logic. Okay, so remember that correlation does not mean causation. So it means that, so it would be the cause. So just like in our situation earlier, so if you have comfortable room, will be the cause of your higher grades. So there are other factors to consider. Okay, so that might be a relationship, but that would not point to the cause. Okay, so and another thing to remember, so remember that our R value should be -1 to +1. Okay, so to analyze correlation, the following statistical techniques can be used. So number one, we have Pearson product moment correlation. So we can use this. So if we have our parametric, okay, So for non-parametric, we will use the Spearman. Okay. So later, so but in this module, we will not discuss that because we only considering this parametric. Okay. So we can use person-product model correlation to measure or prove an existence of relationship between two variables. So this simply measures or tells us how strong a linear association is between two variables. So represented by the person-product model correlation. Okay. So these are the assumptions. So normality, your variable should show an approximately bell curve and plotted on a histogram. So practical implication of this assumption is violated may lead to degraded solutions and biased results. Okay, so take note. So your data should be having this process in normality. Okay, so bell-shaped curve. So I think you already learned that in your statistics and probability in grade 11. Okay, number 2, absence of outliers. So if the data is observed, there are no very high and very low values. Okay, take note of that. And third, level of measurement. Both variables should be either interval or ratio, or what we sometimes call continuous data, like grades, height, weight, temperature, or the scores. Okay, so just like what you use in your data gathering, you have the Likert scale. Okay, so you can use that. So you can use person product moment of correlation. So we have these assumptions. Okay, so this is another counterpart. So like I said earlier, the non-parametric. Okay, counterpart of the person product. We have the Spearman's rank correlation. Okay, or the Spearman row. So when your data involve rank data, so first, second, third, or follows a hierarchical order, grade 1, grade 2, grade 3, and so on. Okay, so you will use that. You will use this Spearman rank correlation. So here we have these assumptions or the requirements for the usage of this technique. So number 1, so the level of measurement should be ordinal. Okay, so ordinal scale. So 5-point scale from very low to very high. Okay. Then 2 paired observations. Observations should be paired. Whether if you get the height of a respondent, so your other data should also come from the same respondent, such as birth order in the family. Okay, so it's paired. Okay, so now we will go to the formula of the person product model correlation. Okay, so we will not discuss Spearman row. Okay, we just discuss here in this module about person product moment of correlation. Okay, so here's the formula for person R. So this is R is equal to summation of x minus the mean times y minus the y mean divided by square root of, so summation of the product of x minus the mean squared times summation of y minus y mean squared. Okay, so these are the legend and this is the formula. Okay, so you just read this. Okay, so let's apply how to use it. Okay, so steps on how to use the formula. So first, you must create this table. Okay, so these are things we need. We have the column for x minus the x mean and y minus the y mean. Then the product of these two, the third column. Then another would be the square of this x minus x mean. Then the last would be the y minus y mean squared. Okay, so remember this in making the table. So you can use Excel. You use to hasten your computations. Okay, so you have here step 2. So first you need to compute the mean. So mean for x and compute for mean for y. So I think you already know how to compute the mean. So you just add these values, divide by the number of items. So Cheval this has 10. So the answer is 2.7 is the mean for x. Then the mean for y is 3.6. Step 4, fill out the table by subtracting the value of x with the mean of x. Okay, so the example 3 minus 2.7 is 0.3 and so on. Okay, so after you get this mean, so subtract it in this column. So 3 minus 2.7, then you put the answer here until you reach the last element in this variable here. Then same process in y. So y has a mean of 3.6, so subtract it in this column y. 3 minus 3.6, you write the answer here until you reach number 2 here. Okay, so same process. And after that, so let's go to another table. So this is the answer for the difference between the x minus the mean, and for the y and the mean. Okay, so I hope you can follow the computation. So just subtract it from the mean. Okay, then we go to the next column, which is the product of these two. Okay, so here is the answer. So just multiply here. So how do we get this? So 0.3 times negative 0.6. The answer is negative 0.18. And 1.3 times 1.4 is 1.82. Okay, so just continue the process until you reach the last. Okay, so 2.72. Then you get the sum of this column, which is 11.8. Then we will now go to the second to the last column. We have x minus the mean squared. So you get the square of this column. So 0.3 times 0.3, that is 0.09. Then is the computation. So just get the square of this. 0.3 times 0.3. 1.3 times 1.3 is 1.69. 1.3 times 1.3, 1.69, and so on. So same process in the last column on the y. Okay. Okay, here's the computation. So we have now completed the table. Okay, as you can see. So just get the square. Then here at the bottom is the summation. So summation of y minus y mean squared. So 12.4. Then for x 12.1. Then the other product is 11.8, and so on. So since we completed already the data, so we can now use it in the formula. Okay, so just simply substitute it in the formula. So here summation of x minus x mean and times y minus y mean. So here's the answers. So here's the summation. Okay, so here, so here's the product. So here's the answer, 11.8. Then next is summation of here's the answer, 12.1 and 12.4. Okay, you substitute. Okay, so I hope you can follow the computation. So 11.8, so multiply 12.1 times 12.4 is 150.04. Then you get the square of that. The answer would be 12.25. Then divide 11.8 by 12.25. The answer would be 0.963. Okay, so that is our result of our person R correlation. Then we'll interpret the result. Over here the table. So the result is positive. Here's the interpretation. So 0.963 is located here in this portion. So you can see it is very high positive correlation. Okay, and if it is negative, so same. So just look at this table. So very high negative, 0.90 to negative 1, 0.70 to 0.89 high negative, and so on. Okay, so just get the table. Okay, so since we got 0.963 as the R value, we can interpret the relationship as very high positive correlation. So we can also say that knowledge and attitudes towards COVID-19 has a very high positive correlation. Okay, now we have the magnitude and direction. So the next phase to check if this relationship is significant. Okay. So here, so how to get the significance? So we solve the t. Okay. So substituting from the values from the table. So our R computed is 0.963. So here's our formula. So 1 minus 0.927 squared. So square of the R. So Rn is 10. So 10 minus 2. Okay. So just follow the computation here. And divide. So the answer would be 10.08. Okay. Then you look at the table. So we have the t table here at the appendices in this module. So just look at the value. Okay. So here you use here the two-tailed test. So under 0.05. Okay, 5%. Then our degree of freedom is 9. So 10 minus 1, 9. So the answer would be 2.262. Okay. So you check if that is greater or lower than the tabular value. Okay. So since our computed value 10.08 is greater than the tabular value, so we can conclude that we will reject the null hypothesis. Okay. So here. So we reject the null hypothesis because it is greater than the t value, which is 2.262. So we reject it. Then so here for the computation, so we have here. So if you use JAS software, so you can have this output also, JAS or VSS. So here's the result of person R, 0.963, T, so this is the table, 10.08, and critical 2.62. Okay. Then this is the format on interpreting a blank or this technique was run to find out the significance, magnitude, and direction of the relationship between what is your variable A and variable B. And the result showed that blank, variable A, and variable B were found to have what is that, positive, high correlation, or negative, and so on. So just follow this. So this is the sample. So person product moment correlation was run to find out the significance, magnitude, and direction of relationship between knowledge and attitude towards COVID-19. Result shows that knowledge and attitude were found to have a significant, very high correlation, which is 0.963. So T is 10.08, our computed T value, which is greater than tabular value 2.262. Okay. So we have now, let's do this. So substitute the given values to the formula and fill out the interpretation format. So this is the title, COVID-19 Awareness and Health Practices of Senior High School Students. So sample 7. Okay, so here's now the data given. So just compute the T. Okay. And the R. Okay. So same process, then you do the interpretation table. Okay. Then, so let's remember this. So Bivariate correlation is linear relationship between two identified variables. So this is the formula. Okay, you can use Pearson R if your data is normally distributed or approximately forms a bell curve when you draw a histogram. So there are no outliers or extreme values. Your values are both continuous data. So when you make a scatter plot, the plot should look like a line going up or down. Okay, so which could say that is linear. So we want to analyze for Bivariate correlation, we can use the Pearson product moment correlation. Okay. Okay, so let's apply this in our study. So okay, in our research, okay, so I know you your mind how to apply this in your. So now we will apply this concept and correlation in your research paper. So let's go back to your research questions. Supposing this is your research question. So what is the level of technical leadership among school heads as observed by teachers in terms of. Okay, so here are the indicators in question number 1. You have 6 indicators. So these are the following. And number 2, so what is the level of employee motivation in terms of. So it has 2 indicators. Okay, so since we are a bivariate, so we're dealing with 2 variables. Okay, so let's go to our questionnaire. Okay, so this is our questionnaire. So as you can see, so here's the questions. It has 13 questions for work motivation. Okay, then for rewards it has 4 questions. Then technical leadership, these are the following questions. Okay, so 6 questions. What you're going to do later is you will encode this in the Excel. Okay, Microsoft Excel or any productivity app that has spreadsheets. Okay, technology and learning. Okay, so these are the questions and items based on your indicators. Okay, so I review this so that you can have a guide in making your table in your Excel. Okay, so supposing this is our first question, it has 13 questions. So how do we going to tabulate our data in Excel? Here is it. So already made this tabulation. So as you can remember in the first indicator work motivation, it has 13 questions. So as you can see, so WM1. So I encoded WM1 for work motivation 1, question 1, question 2, question 3, question 4, to question 13. So based on our questionnaire. So look at the questionnaire. So it has 13 questions. So you put it that way. Okay. Then after that, you have another column for your submin. Okay. Then remember in rewards, so let's go back to the questionnaire. It has 4 questions. So the same procedure. You have these 4 columns here for the rewards. So I have the code R1. So for the reward RW1, rewards 1, rewards 2, rewards 3, rewards 4, then submin. Okay, so you complete this table with all the responses of the respondent in the Likert scale 1, 2, 3, 4, 5. Okay, you just type, example, respondent 1 answered question 1, answered 4, 5, 4, 5, and so on. Okay, till you finish this table. Okay, I'll just type. So type the scores here, just the scores. Later, the mean would be given, the formula. Okay, so here are the indicators. Okay, then after that, so you're now ready to compute the mean. Okay, so here's the mean. So the formula here is round average. So I put round because it will round 2 decimal places. Okay, then average. Here's it. You got the formula. So B5 to N5 is the range of your cells that you want to get the average. Okay, then comma 2 for 2 decimal places. Then enter. Okay, so for shortcut you can have this. As you can see, it has a plus sign. the cursor, then double click it, so it will automatically have the formula applied on this column. Okay, and the same procedure for rewards, the same formula, round average. Then you will now get the overall mean for motivation. This is in green color here, so just get the average of these two. Okay, then same goes to another variable, technical leadership. So same formula, you can see, until you finish all the indicators, then you get all the overall mean. Okay, as you can see, it's highlighted the formula here. So round average and add all the cells you want to get the average, then the two decimal places. Okay, so why are we doing this? Because we will just get the overall mean of each variables. Okay, so we can apply the correlation. Okay, so what I'm going to do next is to copy paste it into another Excel file. Okay, so to making our work faster, so let's just copy this another file. So space it as values because it's formulas. Okay, then another for technical leadership overall mean. Okay, so I just put here a underscore because in just it will not read if you have spaces. Okay, so here are now our data. So this is the overall mean of both variables. Okay, so we'll now plug it to our just. Okay, so I'll save it as, so I'll save it in my desktop. So I will name it as correlation data. So make sure you save it as CSV comma delimited. Okay, because that's the file that will be read by the JAS software, so it cannot read other files. Okay, after this I will now go to JAS. Open your JAS software. Okay, let's wait for a moment, it's still loading. Okay, here's now our JAS. So just open the file. So in our computer, it's desktop. So it's the correlation. Okay, so here are now our data. So we'll now use the correlation in %R. So go to regression, correlation. As you can see, it's already by default %R. So put it in the variables. Okay, and let's see the result. Okay, as you can see, it is 0.80. Okay, so then our p-value is less than 0.001. It means it's significant. Okay, so it means that the higher the technical leadership, so it's same goes to motivation. Okay, so in our interpretation based on our discussion earlier. Okay, so this is how you will apply that concept in your research paper. Okay, so you can copy this table in Microsoft Word. So this is already the format, so you can paste it in your Word. So Okay, just like this one. So you need this table in your research paper. Okay, so I hope you get the process in using just software in determining the correlation of the variables in your study. Okay, so just is a free software, so you can use it. So it's a robust statistical software, same as SPSS. Okay.